All right, let's talk about artificial intelligence. We hear the term AI thrown around constantly, right? But what is it really made of? We're going to peel back the layers and see how it all works, starting with its secret sauce, its most vital ingredient.
So think about this for a second. An email filter and a tool that helps a doctor make a diagnosis. I mean, they couldn't be more different, could they? One is just managing your inbox, and the other is literally a lifesaver. But believe it or not, they come from the exact same place.
And the answer is data. That's it. It's the invisible blueprint that connects pretty much every piece of smart technology you interact with every single day. And it's really the hero of our story here.
So before we can get into the really cool stuff, the intelligent machines, the predictions, we have to start at the very beginning. We have to understand the fuel that makes the whole engine run.
Here's the most important thing to get your head around. AI isn't just born smart. It has to learn. And the way it learns is by sifting through mountains of data to spot patterns. It's figuring out the connection between an input, like the words in an email, and an output, like, hey, is this spam?
That's a great question, because data is a huge catch-all term. It's not just one thing. In reality, it comes in all shapes and sizes, from super organized to just complete chaos. Let's break down what that actually means.
Okay, so this table lays it out perfectly. On one end of the spectrum, you have structured data. Think of a perfectly organized spreadsheet or database, everything in its right place. Then on the complete opposite end, you have unstructured data. This is all your photos, your music, your videos. To a computer, it's just a messy jumble. And then somewhere in the middle, you have semi-structured data, which uses tags and markers to create at least some sense of order.
And this brings us to the first huge challenge. How do you get a machine, which really only understands numbers in neat little rows, to make sense of a song, a legal contract, and a family photo all at the same time? Well, you have to organize that chaos.
And this is exactly what we're trying to do. You see all those raw ingredients on the left? The PDFs, the images, the audio? The goal is to somehow cook them all down into one standardized format that any computer can understand. A simple, clean table. So, how on earth do we do that?
Well, the answer is a really clever process called feature engineering. This is the hard work that happens behind the scenes. It's all about translating everything, text, sound, images, into the universal language of numbers arranged in rows and columns. It's how a photo becomes a grid of pixel values, or a song becomes a sequence of frequencies that a computer can finally process.
Okay, so we've wrangled the chaos. Our data is all clean, organized, and sitting in a nice, neat table. Now, the real discovery begins. Now we get to put on our detective hats and start looking for clues hidden inside all those numbers.
This whole detective phase has a name: Exploratory Data Analysis, or EDA for short. And this isn't about predicting the future. Not yet, anyway. This is all about getting a deep understanding of the data you have in front of you right now. It's where you ask questions, spot weird anomalies, and maybe uncover connections you never ever expected to find.
So what does this EDA process look like? Well, it usually has 4 key parts. First, you use that feature engineering we just talked about to get the data into tables. Then, you use math and statistics to find potential relationships. But, and this is so important, you need domain expertise. You need real-world knowledge to figure out if those patterns actually mean anything. And finally, you use powerful programming languages like Python and R to do all the heavy lifting.
All right, we've gathered all our materials, we've studied the blueprints. Now, with our clean, well-understood data, we are finally ready to build something intelligent.
I just love this quote because it sums everything up so perfectly. All that data prep and analysis we just went through, that's data science. It's the solid, concrete foundation. And only once that's in place can you start building the incredible structures of AI, machine learning, and deep learning on top of it.
So let's get our definitions straight, starting from the very top. You have artificial intelligence, or AI. This is the biggest, most general category. It's the whole dream of creating machines that can learn, reason, and understand the world in a way that feels human. Now, inside that giant AI bubble, you have a specific field called machine learning, or ML, and this is where things get really cool. With ML, instead of a programmer trying to write code for every single possible outcome, you just give the machine a ton of data and let it figure out the rules for itself. That's exactly how our spam filter works.
And if we zoom in one level deeper, we find deep learning, or DL.
This is a superpowered version of machine learning. It uses these complex structures called neural networks, which are kind of inspired by the human brain, to learn from absolutely enormous amounts of data. This is the technology that's driving things like self-driving cars and really advanced image recognition.
Okay, so we've followed the entire journey, from messy, raw files to organized tables, and finally to these incredibly smart systems. But what's the actual payoff? Let's bring this whole thing back down to earth and see what it all means for you and me.
And this is where it all clicks. That abstract task we call prediction, well, that's just your daily weather forecast. Classification, that's our old friend the spam filter, or a system that helps a doctor spot diseases in a medical scan. And clustering, that's how companies can group customers together to figure out what they might want to buy next.
So when you boil it all down, this is the whole process. Every AI you use is the end result of this incredible journey. A journey that takes raw, chaotic information and transforms it, step by step, into clear, actionable intelligence that really does power our modern world.
And that leaves us with a pretty wild thought to chew on. Today's intelligence is built on the data we have now. But what happens in the future when literally every object around us, your car, your coffee cup, the road you walk on, is constantly generating new data? What kind of intelligence are we going to build then?